Welcome, and thank you for attending. In this seminar, we will explore using SoundCheck for production line or end-of-line audio testing. We'll take a close look at SoundCheck's architecture and why it's perfectly designed for transitioning testing from the R&D lab to the production line. We would also like to extend a thank you to S&V Sanford for their help in organizing this presentation. This seminar will focus on SoundCheck for production line or end-of-line audio testing. We're going to cover how to scale for high-volume production testing, saving time and money, typical audio measurements used in production testing, production test setups, optimizing test times and accuracy, setting pass and fail limits in a test sequence, auto-saving data, custom step applications, controlling SoundCheck externally from another program. SoundCheck is a fully modular audio test system that can be configured for your exact test requirements. The system is built on the idea of one system, many configurations. This architecture allows us to precisely spec out a test system that meets individual test requirements, both software and hardware. It also allows for easy transition of testing a product from the R&D lab to the production line, all while remaining in a single familiar test environment. Audio testing needs are different between the two environments. In the development phase, you are interested in fully characterizing your product. Typically, you have time to carry out tests, so you can use longer test stimuli. You might test using different stimuli, like frequency step or continuous sine sweeps, amplitude sweeps, multitone, pink noise, speech, or even music. Maybe you want to perform directivity tests, for example, polar plotting on-axis and off-axis response using automated turntable control or a multi-channel horizontal and vertical microphone array. In short, you have ultimate flexibility for all kinds of parameters, even the unknown. These are all important tests in R&D, but impractical on a high-volume production line. On a production line, your objective is different. Ideally, you will perform a limited number of tests in a short amount of time and qualify whether the product is suitable to ship. Test speed, accuracy, automation, noise immunity, and lower system costs are all important considerations. With this in mind, let's take a closer look at SoundCheck. The software license is fully modular. Options are added to specifically meet your test requirements. You can view the configuration on your software license from SoundCheck's optional modules window. The left side displays modules active on the license, and you can see my license is fully loaded. In contrast, the production license may have a limited number of active modules necessary to perform end-of-line tests. One might remove the sequence editor module or instruments not needed for production tests. This allows you to create lower-cost licenses, and when combined with quantity discounts, you can save a lot when scaling for multi-system production testing. Acquisition hardware is also an important consideration for SoundCheck production test system. Listen's all-in-one test interfaces, including the AmpConnect ISC and multi-channel AmpConnect 621, are both simple to use and cost-effective. Both interfaces integrate an audio interface, microphone power supplies, a power amplifier, and current sensing circuit for impedance measurements. They connect with a single USB connection to your computer, and because they are true plug-and-play and come calibrated from Listen, installation is fast and easy. The all-in-one design eliminates cabling issues between individual hardware and reduces overall costs, all important considerations for the production line. Let's look at some electroacoustic measurements you can perform in SoundCheck. Everyone is familiar with frequency response, represented on an XY graph where the x-axis is frequency and the y-axis amplitude or level. The analysis is done by comparing the test stimulus to the recorded response. Usually you want a flat curve with minimal peaks and dips. In SoundCheck, there are many ways to characterize frequency response using different test stimuli like step sweeps, wideband pink noise, a reference wave file of speech or music, and even simulated free field measurements using time selective response. Frequency response is an essential measurement for production testing. SoundCheck has many ways of characterizing distortion. Most common is THD, or total harmonic distortion. This measures the fundamental with the resulting harmonics from the response and represented in percentage. But there are many other types of psychoacoustic distortion that SoundCheck can characterize, including rub and buzz, or higher order harmonic distortion, perceptual rub and buzz, which applies a perceptual loudness algorithm, and loose particle detection, non-harmonic based transient distortion. Distortion is also an essential test for production. A big advantage of perceptual rub and buzz is that it more closely resembles how the human ear perceives distortion. This will result in higher pass yield versus traditional rub and buzz distortion, which just looks at high order harmonics but is not necessarily audible. We're very excited about our new enhanced PRB algorithm, or ePRB, releasing with SoundCheck 20. This new algorithm offers far greater repeatability and reliability than any other perceptual rub and buzz algorithm out there, making it ideal for use in noisy production environments. We'll demo ePRB in depth in a separate seminar very soon. Impedance. This identifies the max impedance, and you can also calculate the resonant frequency and Q of the resonant peak, which are all important quality factors. Polarity. Positive input signal causes the loudspeaker or device to move out. Good for identifying potential wiring problems in production testing. Other tests include directionality or polar plotting, time frequency analysis, teal small parameters, and international standards, all generally good tests for R&D, but not practical for production testing. Let's look at some setups. SoundCheck's flexibility means that it's completely adaptable for production testing at different stages. Component testing, for example, a loudspeaker or microphone, a subassembly, like a multi-channel hands-free microphone array, or a finished product, like a loudspeaker or hearing aid. Let's look at some of these setups. Here's a simple loudspeaker test setup diagram for production. SoundCheck runs on a computer connected to a test interface like AmpConnect ISC. A test signal is sent to the speaker under test. The response is recorded from the reference microphone, analyzed, and the results are passed through pass-fail limits and displayed on graphs. On a production line, the speaker may be tested in a test box, which better isolates the speaker and optimizes signal to noise, critical for characterizing distortion. Here's a microphone test setup. The challenge with testing microphones is that the microphone under test almost always has a better frequency response than the source speaker playing the test stimulus. To avoid measuring the speaker, SoundCheck offers two techniques: calibrating and equalizing the source speaker to have a flat response, or mic substitution, where the mic under test is measured and then compared to the same source speaker measured using a reference microphone. The critical measurements for production microphone testing are frequency response, average sensitivity, and sometimes self-noise, also known as equivalent noise. Of course, SoundCheck can test devices at the component level. We can also set up complex tests of finished products. For example, smart speakers with speakers and microphones, and hearing aids. Let's look at a sequence. This is SoundCheck's loudspeaker complete test sequence. This is installed with SoundCheck and a great example of a production test sequence. It measures frequency response, distortion, including THD and rub and buzz, impedance, average sensitivity, and polarity. It also includes pass and fail limit steps and final displays. Here's the sequence editor with the test sequence steps on the right. In short, the sequence defines the test stimulus, performs an acquisition, i.e., it plays the test stimulus to the speaker and acquires the response via the reference microphone. After the acquisition, the sequence compares the test stimulus to the recorded response and performs some analysis. Let's look at a few of the sequence steps. First, the test stimulus. This is an example of a SoundCheck compound stimulus. You can see there are two parts of the stimulus, a high-frequency sweep and a low-frequency sweep. The first part sweeps from 20 kilohertz to 300 hertz at a 12th octave resolution. The second part sweeps from 250 to 50 hertz at a 3rd octave resolution. The advantage to using this stimulus is that we can keep test times down without compromising the accuracy of the test. The lower frequencies, we have wider cycles, so we can use a lower resolution. Most importantly, if we tested at a 12th octave resolution across the full frequency range, we would have more than doubled the test time. There are other great uses of compound stimulus in SoundCheck. We can prepend noise before the test sweep and use it as a conditioning tone, effectively inject energy into the speaker to warm it before performing the measurement. We could put a tone or chirp at the beginning of the test signal when performing a trigger record in SoundCheck. Effectively, SoundCheck will trigger into record if the tone or chirp is identified and the input threshold is met. There's even an Analyze checkbox, so SoundCheck only analyzes the intended stimulus. Let's look at the analysis step. We actually introduced the harmonic track algorithm way back in 1995. When used with a step sine sweep, SoundCheck can analyze both the fundamental and harmonics with one test stimulus and analysis. This saves time when you need to measure frequency response and distortion on the production line. Also, since the step sweep stimulus uses discrete frequencies, the filtering used in the analysis does a good job at rejecting background noise, also important on factory production lines. Let's look at pass and fail limits. Limits are essential for qualifying your device on a production line. Setting limits in SoundCheck is fast and easy. The sequence has some default arbitrary limits. Many of them have failed because I didn't specifically set the pass-fail limits to conform to this particular device under test. There are two common methods for setting limits. One, measure golden reference unit and build acceptable plus-minus tolerances from the reference unit. Or two, measure a large sample and use SoundCheck statistics. Let's look at the limit step for the frequency response in this sequence. This is an example of a multi-point limit X and Y axis. I could edit either axis manually, or I could use a curve from my memory list, set an upper threshold and lower threshold, and then apply the step. Similarly, I can run statistics on a larger sample of curves, determine the mean, and use the average curve as the reference for a limit. For example, plus or minus 3 dB sigma or best fit to average. For single values like average sensitivity, the upper-lower limit will also be a single value. A limits display can show the limits and the yield, or just display the overall pass and fail, which may be all the test operator is concerned with. Next, let's look at the autosave step. There are many reasons why you may want to autosave data in production. If you're a supplier, maybe you want to print out data of your own data sheets correlated to the product serial number or lot number. Maybe you collect measurements for the day, run end-of-day statistics for quality control to assure the production line is not drifting over time. Maybe you want to autosave to an SQL database so you perform your own sophisticated queries. Maybe some of your engineers want to output MATLAB format for further analysis. If you're not familiar with SoundCheck, it's very easy to build sequences with drag and drop. I'm going to add an autosave step to this sequence. The autosave step allows you to select data organized by type on the left and choose the format of the saved data. From the drop list, you can see a list of data types, including Excel, MATLAB, SoundCheck native file format, and text. Using append, we can keep a running file of each iteration of your test run. For example, one Excel file versus a separate Excel file for each sequence run. You can also control the naming format of your autosave data. Most recently, we improved SoundCheck's autosave to database file format, and as a result, saving to database is faster and more efficient. If you're familiar with the Watts test data management software, we've recently developed a utility that will convert SoundCheck-generated text files directly into Watts for further analytics and process management. SoundCheck's custom step is yet another powerful way to customize your test sequences for the production line. Custom steps are executed like any other step in SoundCheck. However, you have full control of what the step can do. There are two ways the custom step can be used. One, develop your own LabVIEW custom VI, which can be run as a step in SoundCheck. Here are a few that we created. Your own LabVIEW custom VI can populate this list. The SoundCheck User's Manual provides full documentation on how to link your LabVIEW custom VI as a custom step in SoundCheck. 2. Run your own exe or batch file by pointing the system custom step to it. For example, if you have software control of your device, you could put it into test mode or control any other custom functionality of your device as a step in SoundCheck. Another application might be programming software control of a reference mic to position it on an XY plane. For example, you might use a custom step to position the mic prior to the acquisition step. Another powerful capability for production testing in SoundCheck is external control via TCP/IP. TCP/IP external control is operating system and programming language agnostic, so you can fully program in an environment that's familiar to you. The common application of external control on the production line might be using SoundCheck as one part of a larger overall test stand. SoundCheck handles all the audio tests for the device, but the full test stand may test other parts of your device like circuit boards, haptics, etc. SoundCheck runs in the background, and in some cases, the test operator may entirely run a different GUI and never even see SoundCheck. TCP/IP control is enabled through SoundCheck's preferences, and we provide external control examples along with full documentation, including the command set and return format to get you started. This concludes our presentation today. We hope this seminar shows you why SoundCheck is the most flexible and customizable solution for your exact end-of-line testing specifications. SoundCheck's lower-cost packages make it the ideal, scalable solution for high-volume production testing. If you would like to discuss your specific production needs, we welcome you to reach out to myself or your local listen sales engineer. Thank you.